Thank you, of course, to everybody, to Marco, Fabrizio for inviting me, of course, and also for the discussants who are willing to destroy my paper. Okay, I'm going to cover a lot of ground, so better start immediately. So the title of the presentation says it all, I think. So I'm going to talk about the structure of sensorimotor explanation. Now, before I go into the details and explain a little bit the structure of the paper, let me summarize a little bit what is the main question that I'm going to address, and also what I'm going to say, what I'm driving at. Okay, it is still not clear, basically, whether the sensorimotor theory, which I'm going to call for short SMT, of vision and visual consciousness, can mark a significant departure from what Thompson and Noé call the orthodoxy in vision science. And now, basically, the orthodoxy consists in representationalism and computational functionalism. So a typical example of the orthodoxy, one of the favorite targets, critical targets of Kevin Regan and Alvin Noé is, of course, David Marr. Now, it isn't very clear, however, as I said, that, whether the sensorimotor theory provides a radical, revolutionary alternative to the orthodoxy. Now, what I'm going to do is to assess this challenge by studying the explanatory structure of the sensorimotor theory. And the verdict would be, well, that the standard formulation of the sensorimotor theory is basically consistent with the framework of nomothetic explanations, a covering globe explanation. So basically I claim that the standard formulation of the sensorimotor theory, the standard formulation is basically whatever you can find in the current literature about the sensorimotor theory, subscribes to this view of explanation according to which there are some sort of laws and the phenomenon we want to explain is somehow subsumed under these laws plus antecedent conditions. But the claim is then I'm going to make is that if that is the form of explanation in the standard sensorimotor theory, then it exposes to two issues. One is the role of representations, which is made just problematic. And the other more serious issue is the so-called mere description worry, which is familiar to everyone working on the literature on mechanistic explanations. Then I'm going to advance the claim that actually both problems can be solved if we upgrade the SMT to a mechanistic version. And actually, as I'm going to show, the SMT can be mechanized rather easily by analyzing some examples of purported sensorimotor law. Okay, now that's enough as a kind of introduction. Let me move on to the structure of the presentation. So first, I'm going to talk about the core thesis of the sensorimotor theory and then move on to the dynamical hypothesis in cognitive science. A crucial step here would be in likening the sensorimotor theory to the dynamical hypothesis in cognitive science. Second step would be to study and unfold a little bit about the explanatory structure of the standard sensorimotor theory. Then move on highlighting the problems with these standard sensorimotor theory, form of explanation of the sensorimotor theory. Then I'm going to argue that SMT is compatible with the mechanistic account, and finally draw some implications and conclusions. So basically, for those of you who have read the paper, which of course contains many more details than I can actually cover in the oral presentation, it's basically the same structure. Okay. So let me start with an outline of the sensorimotor theory. That's the very first step. Okay, so I think that all in all we can single out some core theses of the sensorimotor theory. Core theses that are that define actually the very essence of this sensorimotor theory. Of course, there is much more to be said, but these are the most important aspects of it. Now, the first thesis is that the sensorimotor theory seeing is constituted by the active exercise of our sensorimotor skills. Now, the crucial notion here is that of a sensorimotor contingency, which Kevin O'Regan and Alvin Noé define as the sensory changes produced by various motor actions. Now, of course, sensorimotor contingencies are not a novelty in cognitive science. Cognitive scientists have been long aware of them. Examples drawn from the history of cognitive science from the relatively old literature include Cliff and Mackay's work, but the sensorimotor theory is making a much stronger claim, namely that seeing is literally constituted by the active exercise of our sensorimotor skills. Let's move to the second claim. Second claim is that the sensorimotor skills obey a set of sensorimotor laws or regularities. This will be one of the central theses, the thesis that will feature at the center stage of the later parts of my talk. So the idea is that these sensorimotor changes are not random. They in some sense obey a kind of regularities or what they call law. The next thesis is that perception is not constituted by static pictorial representations of the environment. I'm going to elaborate a little bit more on that in a couple of minutes. This claim might be controversial and will be one of the central parts of the discussions afterwards about the role of representations in the sensorimotor theory. The fourth thesis says that the perceiver is an agent that is part of a dynamical system. Actually, in many publications, Alvin Noé especially, and also together with Susan Hurley, stress that perception is a kind of skillful but active activity, so to speak. The perceiver is an agent in the dynamical context. Seeing involves actively interacting with the world, says O'Regan. So this is an integral part of the sensorimotor theory. Finally, the fifth thesis says that cognitive processes are partly constituted by the environment. Okay. Well, regarding these fifth thesis as a kind of textual evidence, this would support a kind of version of vehicle externalism in different passages. Actually, the authors stress that cognitive processes are partly constituted by the environment. Okay, now let's move on a little bit and let's focus on the problem of representations. Now, I want to specify that because very often, it happened to me in many conferences that people think that, mistakenly I think that the sensorimotor theory of vision is an anti-representationalist thesis, that Alvin Noé and Kevin O'Regan believe that there are no representations at all in vision. Actually, there is good textual evidence to think otherwise, and here I want to mention a couple of passages. For example, Alvin Noé in his book published in 2004 says that the claim is not that there are no representations in vision. That is a strong claim that most cognitive scientists will reject. The claim, rather, is that the role of representations in perceptual theory needs to be reconsidered. Okay, that's pretty clear. The point is not there are no representations, but we should reconsider their role. O'Regan, more recently in his book, Why Red Doesn't Sound Like a Bell, claims very clearly here, I think, information from the outside world must be processed in the brain, and thus it must somehow be represented. Again, I think this is pretty clear about the presence of representations in the brain. In the paper version, actually made some more claims because it is actually a matter of controversy whether perceptual states at a conscious level or personal level are representational or not, and or whether representations are confined at some kind of subpersonal level. That doesn't bear on the arguments I'm going to make in this presentation. But it is absolutely crucial to understand here that even though there are representations for the sensorimotor theories, apparently, as these textual evidence suggest. They reject what they call the orthodoxy, the claim that visual perception is a process whereby the brain builds up detailed representations of the environment on the basis of the sensory inputs. And then remember David Marr's different stages of constructing the representations of the external world. Okay. In this sense, Evan Thompson, Alvin Oye, Kevin O'Regan locate the sensorimotor theory within the family of theories which they call heterodox approaches. So basically, heterodox approaches are very different theories about visual experience, but they all downplay the role of representations or simply reject them altogether. Now, the textbook example here is, of course, Gibson's ecological optics. Other examples include Ballard's animate vision, and so on. Okay. One problem that this standpoint raises is that if the defenders of the sensorimotor theory do not reject representations, then the question is, what is their role within in the brain? I mean, as I'm going to say, of course, if the brain bothers creating representations of the environment, which involves quite a lot of machinery, what's their purpose? What's the point of doing that? Okay, now, as I said, it would be an integral part of this, my argumentative structure to claim that the sensorimotor theory is very similar to the stronger dynamical system, dynamical hypothesis in cognitive sciences. So I'm going first to sketch out very briefly what dynamic system theory says and then introduce the dynamical hypothesis now. Okay, dynamic system theory, as you all know, is based on the notion of a dynamical system, which is a mathematical description of how things change with time. Houghton and Yoshimi, I think, in this paper very helpfully enucleate the two main properties of dynamic system theory, which are here formalized, but in a more informal way, we can say that the first property says simply that there is a time t0, which is the present state of the system, and that each state S1, S2, and Sn must be mapped to itself in the present moment. And the second property says that the future states are uniquely determined by the present state. Okay. In this formulation, the dynamic system theory actually isn't in opposition with the so-called orthodoxy. So many vision scientists working on dynamic systems within the research of dynamic system theory using these tools do not reject representations, for example. So nothing here entails a rejection of representations. But there is some philosophers, as we know, make a stronger claim. They advance the claim that dynamic system theory provides a new paradigm for the study of cognition in general, and in our specific case, as we will see, visual perceptual experience. Now, these researchers, among them Randall Beer, Port, and Van Gelder. Van Gelder perhaps is, as you know, the single most important philosopher who has worked on trying to enucleate the core philosophical thesis of the dynamical hypothesis. They are making a stronger assumptions. They are making a stronger claim. Their claim is that using a dynamic system theory, we can get rid of a number of assumptions, erroneous assumptions, according to their opinion, made by the orthodoxy. They reject the full representations, they reject a way of studying the mind, in short. The following passage is meant to enucleate different theses that I'm going to single out in short. So in this famous passage, which is kind of manifesto of the dynamical hypothesis in cognitive science, they say, the cognitive system is not a computer, it is a dynamical system. It is not the brain, inner and encapsulated, rather, it is the whole system comprised of nervous system, body, and environment. The cognitive system is not a discrete sequential manipulator of static representational structures. Rather, it is a structure of mutually and simultaneously influencing change. Its processes do not take place in the arbitrary discrete time of computer steps. Rather, it unfolds in the real time of ongoing change. The cognitive system does not interact with other aspects of the world by passing messages or commands. Rather, it continuously co-evolves with them. Now, What is interesting about this passage is that we can single out the following 5 claims, which are called DH1, cognition is an activity that unfolds over time. DH2, the agent is embedded in a dynamical context. There are no static representations. The cognitive system is partly constituted by the environment, and the dynamical system obeys a set of specific dynamical laws. Now, this claim, this latter claim, that DH5 is not actually included here in the passage I've just read. It is kind of what Carlos Zednik, in an influential paper, called the received view about explanation in dynamic system theory, that dynamical systems, models of dynamical system actually afford covering law explanations, where the role of law would be taken up by differential equations usually, which are meant to support counterfactuals. This intuition was first introduced by William Bechtel in the 1998, if I remember well, was also present somehow in Andy Clark's older book, Being There, published in 1997. There is also another influential paper elaborating on that view by Walmsley, published in 2008. So that would be exactly the standard view about the dynamical hypothesis. And as you might have noticed here, this list of features is very similar to the core thesis of the sensorimotor theory. Actually, if we put them in a table, we can compare them. Sorry that the list is a bit messy because DH1 does not actually exactly correspond to T1 of the sensorimotor theory, but the theses are roughly equivalent, for example. Now, my hunch here is that actually the sensorimotor theory basically shares a number of assumptions which we find in the dynamical hypotheses in cognitive science. Now, as I said again, and I want to stress that the dynamical hypothesis is not equivalent to dynamic system theory. So we have on the one hand dynamic system theory, which is making some particular claims about how to study cognition. It makes use of the mathematical tools of dynamic system, but it's not equivalent to the dynamical interpreted dynamical hypothesis, which is a particular philosophical interpretation of what dynamic system theory affords. So we should distinguish them. Okay, so I've already hinted at the fact that the sensorimotor theory seems to share these covering law structure of explanation with the standard mainstream view regarding the explanation afforded by the dynamical hypothesis. Now let's move on and examine the explanatory structure of the standard formulation of a sensorimotor theory. Remember that the standard formulation of a sensorimotor theory, as I said before at the beginning, is just the actual current version of a sensorimotor theory, which I then put in contrast with my own view, which is a mechanistic perspective on the sensorimotor theory. Okay. So, as I said, proponents of the dynamical hypothesis often state that dynamic system theory is subject to explanatory norms that are different from those of classic computationalism and connectionism, and that they would provide covering law explanations. Now, I think just a classic in the literature of the paper by Carlos Zednik that I'm mentioning here. Now, you all know what covering law explanations and mechanistic explanation are, but maybe our audience does not, so let us repeat it very quickly. Covering law explanations is basically a case where a phenomenon is explained when it is subsumed under one or more laws of nature plus statements of antecedent conditions. Usually it takes the form of a deduction. In this case, then we have a complex argument where there are different premises, laws, and statements of antecedent conditions form the premises, and the conclusion, which describes the explanandum phenomenon, is then deduced from the premises. Now, this model of explanation, as we know, has been subject of the critical target of many criticisms. Defenders of mechanistic explanation, on the other hand, claim that a phenomenon is explained when either we describe the causal chain of components and activities that causes the phenomenon. This is the case of a theological explanation, or when we explain how the organized set of parts and activities jointly constitute the explanatory phenomenon, and that is the so-called constitutive explanation. Okay, so far so good. Now, let me try to explain why I think the Sensorimotor theory subscribes to a covering globe model of explanation. So, now first, according to Alvin Noé and Kevin O'Regan, as I said, the sensorimotor contingencies are not run into a void. They actually obey a kind of sensorimotor law or regularities. Though we will mention again there is of course a distinction for those of you who are familiar with the topic between laws and regularities. They actually use the terms apparently in synonym and equivalent terms. So sometimes we speak of sensorimotor laws, sometimes we speak of sensorimotor regularities. They are never really clear about what is sensorimotor laws or regularities. Are they actually in their original paper published in the Behavioral and Brain Sciences make a few examples that might shed light on the nature of these sensorimotor laws. So let us examine this example more closely, but first let me say that they distinguish between two distinct sets of laws. The first set of laws are those related to the visual system, and here a famous example is that discussed in the original paper is that of the eye movement. So this picture is meant to illustrate precisely what happens to the representations of the environment when the eye moves upwards or downwards. And so the representation peters out and changes according to laws of optics here and according to the form of the eye and how the light enters in the eye and impinges the retina. So that would be the first set of laws. The point is that the representations on the retina, the word representation is used by the authors themselves, changes in a lawful way. The second example is that is more of sensorimotor laws specific to the so-called features of vision, like shapes, colors, and so on. We can gloss over how many features there are in vision, and there is, of course, a great big debate about what basic features there are and what are complex features. But the point made somewhat obscurely, I think, by Alvin Noé and Kevin O'Regan is that the case of shape perception is that shape perception precisely consists in the set of all potential distortion that the shape undergoes. What happens is that by observing and sampling the environment, the brain, according to defenders of the Sensorimotor theory, would abstract a series of laws that actually constitute shape perception. That's somewhat unclear to me, at least, and I'm going to further elaborate on this suggestion. But now let me examine also a more recent example of sensorimotor theory, because in a paper published a few years ago, Burman and others have tried to provide a dynamical formulation of the sensorimotor theory. Now, I will use the previous two examples as well as the Burman and colleagues minimal model as a kind of foil to elucidate the explanatory structure of the sensorimotor theory and to explain also why it conforms to a mechanistic account of explanation. Now, this paper is illuminating for many aspects, I think, because first of all, Burman and collaborators start by making the claim that although the sensorimotor theory is making a number of important claims about the nature of visual perception, in its philosophical form, it is of little value for actual empirical research. So we need to operationalize some of the concepts and articulate more robust mathematical formulations of its core concepts. They have therefore constructed this minimal model that I'm going also to examine later. Let's introduce it first. This is a dynamical model of the sensorimotor theory. They define the organism and its environment as a coupled dynamical system that can be described by a set of differential equations, as we are going to see. Now, that's basically the description of the system here. Significantly, they actually introduce a few more sets of sensorimotor laws. As we have seen, there are, for Albanway and Kevin Regan, 2 sets of sensorimotor laws. So those were connected to the visual system, and those related to the specific visual features. According to Burman and their collaborators, it would be sensorimotor contingencies related to the sensorimotor environment, to the sensorimotor habitat, coordination, and strategies. This is not a radical change of the original formulation of the theory, it's just a kind of enrichment of it. And as we are going to see, it basically preserves the core intuitions of the sensorimotor theory. Now, why the standard sensorimotor theory exposes a covering law model of explanation? Well, first, it lays emphasis on the search for laws. Now, there are many passages in their works that stress these important aspects, but I've singled out this quotation here, drawn from the, what I call sometimes the original paper. It's the paper published on Behavioral and Brain Sciences. It says that we must direct our investigations not on some ineffable inner event, but rather to the temporally extended activity itself, to the laws that govern this activity. Now, the point seems pretty clear. So the point is not that we should look for something ineffable in the brain that would explain visual perception, but actually identify the law that regulates somehow the skillful activity of exploring the environment visually. Now, such laws then would help us explain visual perception in a deductive way. Now, let me mention this passage again. Suffice it here to say that it is possible to deduce things about the structure of outside physical objects by studying the laws relating movements that an organism makes to the resulting changes in sensory inputs. Another passage drawn from the same book by Kevin Regan, why red doesn't sound like a bell, like the law of gravity that described how objects fall. These laws, the sensorimotor laws, describe how changes made by our body provoke changes in the information coming into the sensors. Now, it has been pointed out to me by a referee when I first submitted the paper that actually this passage is meant to describe the work of the brain. So there is a little bit of interpretation controversy regarding this passage in the context. So apparently the brain would deduce actually things about the structure of outside physical objects, but there is also some textual evidence that shows that actually this is precisely what scientists are doing when we're trying to explain visual perception. What we are doing is to basically set up a deductive argument. Okay, so I think the basic structure of the standard formulation of a sensorimotor theory could be something like that. So we have a set of premises. Among the first premises, we find sensorimotor laws of the visual apparatus. Remember the example of the eye. Another set of premises, again, laws, would be the sensorimotor law of visual attributes. That would be a plural here, actually, sensorimotor laws. Sorry for forgetting the S. Another set of premises would be the statements of antecedent conditions, commenting it in a second, and the second set of premises is the standpoint of the target. Now, regarding the first antecedent conditions premises, target object O, the defenders of the sensorimotor theory endorse a form of disjunctivism in philosophy of perception. Now, disjunctivism is, roughly speaking, the claim that when we are in a genuine perceptual state, we're not in the same perceptual state, we're not in the same mental state as when we hallucinate an object. Now, this claim, the antecedent condition number 1, target object O, basically is an expression of the fact that there must be an outside object in order to trigger our mental state of seeing that object. The second premise is that the standpoint of the agent, I borrow the term standpoint from John Campbell's work, where it basically is used to refer to various factors like the sense modality involved, the relative orientation of the agent, its distance from the object, and many other factors, which are relevant to pin down exactly here. So, and from this set of premises, we will be able to draw the conclusion that conscious visual perception of O happens. So basically, we explain how the conscious visual perception of O takes place by subsuming the phenomenon under these set of premises. Okay. Now, before I criticize this and try to articulate my mechanistic interpretation of the sensorimotor theory, let me mention some problems that derive from it. Briefly, the first worry is related to the role of representations. Now, the point is that, as we have seen, there's good reasons to believe, at least, that there's textual evidence in support of this claim, at least, that defenders of the sensorimotor theory do not deny the existence of representations at all. They kind of believe that they are explanatory relevant, apparently. If we want to explain how the subject comes to see the world and explore the objects in front of it, in front of him or herself, we don't need representations to do the explanatory job. Actually, it appears that the explanatory job is took up by the sensorimotor laws. Notice that the formulation I've given of the sensorimotor theory now with these in its deductive form is compatible also with the enriched view proposed by Bormann and collaborators. So in that case, instead of having just two sets of laws as premises, we can enlarge it up to 4, as they have suggested. So the point is now is that if representations do not play a role in explaining visual perception, and apparently, according to Noé and Reagan, we should reconsider their role in vision. The question is, what are they for? So if the brain bothers creating representations of the external environment, what is their role in the organism? Now, we tend to think that this issue, though important, is less serious, so to speak, than the second issue, which is familiar to everybody working on the literature on explanation, which is the mere description worry. Now, the fact that we can't sometimes afford predictions that do not suffice for generating explanations, so sometimes some regularities or laws may be merely phenomenological in nature. Now, as we know, phenomenological models are very helpful models in cognitive science. They are helpful in sometimes, they play many roles. Sometimes they are helpful in approaching an issue and trying to see whether we can successfully study a particular target via, say, mathematical modeling, concrete modeling, or computational modeling, for example. That's Weisberg taxonomy here I'm referring to. Some other times, phenomenological models play other roles, like exactly generating predictions and so on, but phenomenological models refrain from postulating the exact mechanisms and causes underlying a phenomenon. Now, the point here of the mere description worry is that it is very unclear why this law apply in the first place. So how can we tell that the sensorimotor laws actually are explanatory and not merely descriptive? This is the core intuition behind the charge of predictivism raised against the dynamical hypothesis in cognitive science. So we want to look for explanations, and we don't know exactly whether these regularities do afford the kind of explanations we are after. As Zednik, I think, in a perfect way here summarized in a passage drawn from his paper, as long as dynamical explanation is viewed as a form of covering law explanation, the mere description worry looms. And the same goes, if I'm right, for the sensorimotor theory as well. So basically the point now is that the sensorimotor theory is perfectly consistent with this covering law model of explanation, and as we have seen, the covering law explanation leads the sensorimotor theory to two problems: determining the role of representations and the mere description worry. Now, how can we sidestep this issue and try to fix the sensorimotor theory? Well, there is a way, I think, if we go for a mechanistic interpretation of the sensorimotor theory. Now, let me specify. There is a current controversy about whether covering law explanations are really explanations or not, at least in the case of dynamic system theory, the dynamical hypothesis. Some authors actually tend to think like Loren Ross, that in some cases at least, like Ermentrout and Coppel's canonical model does not meet the requirement for mechanistic explanation, and yet neuroscientists consider it to be explanatory. Now, my stance would not be that of trying to adjudicate the question of whether the covering law explanations in the dynamic system theory are really explanatory or not. One thing is clear: no one denies that mechanisms explain. So if we can't show that the sensorimotor theory is consistent with the mechanistic interpretation, then we know it can be explanatory. And that's precisely what I'm going to do. If, therefore, someone is up to trying to reject or articulate a rebuttal on my position, one could reasonably try to claim that the regularities that sensorimotor theory picks out as explanatory really are not reducible to mechanisms, and they do still play an explanatory role. Well, let's see. Okay. Now, according to some researchers, as I said, generalizations of dynamical systems are explanatory because they describe the causal relationship that produce, underlie, or maintain the explanandum phenomenon. This is Kaplan and Craver, and Kaplan and Bechtel, because basically they describe mechanisms. So when we identify a regularity, that regularity might play an explanatory role because it is precisely generated by an underlying mechanism. And that's why we can regard it as explanatory. Now, as I said here, as a matter of debate, whether all dynamical explanations are mechanistic in nature or not. Basically, this part is repeating what I've just said, but the point is that if we can show that the sensorimotor theory can be mechanized, upgraded to a mechanistic perspective, then it can just sidestep a number of problems connected with predictivism and covering law explanations. Okay. Now, the central part of my claim with that, if the sensorimotor theory is compatible with this mechanistic interpretation, then it can be shown that the sensorimotor theory, after all, is not a radical alternative to the orthodoxy. Actually, it can be reconnected with it. That's the price we pay to making the sensorimotor theory explanatory, in a sense. Now, let's not jump to the conclusion too fast. Now, how can we show whether the sensorimotor theory is mechanizable or not? Now, the most famous criterion here has been made by Kaplan and Craver in an influential paper. They call it the 3M criterion. Let's read the passage here, drawn from their paper. In successful explanatory models in cognitive and system neuroscience, the variables in the model must correspond to components, operations, that's my change of the term, but it's not relevant here, properties and organizational features of the target mechanism that produces, maintains, and underlies the phenomenon, and B, the perhaps mathematical dependencies posited among these variables in the model correspond to the perhaps quantifiable causal relations among the components of the target mechanism. Okay, now what I'm going to do is basically to re-examine the examples of sensorimotor laws in light of this criterion. I will start with the fun aspect, it means Burman and collaborators model. So Burman and others have proposed, as I said, a minimal cognition model following the research of Randall Beer and the Sussex School, specifically the work of Harvey and collaborators. Now, basically, this model, which is pictured here, the picture is drawn from from my paper and from Burman and collaborators' paper, describe precisely this minimal agent. So we have an agent which is the big circle in the bottom, which can move horizontally, basically, within a one-dimensional environment, and contains two bell-shaped gradients with different widths that are detected thanks to a distance sensor. Okay, the distance sensor is the delta S you see in the upper side of the big circle, and there are, as you see, two curves, two Gaussian functions. And basically the agent can move horizontally here. Now, Here in this model, the environmental states E are described by the Gaussian functions that describe the two shapes, where H is the height of the shape, X is the position of its peak, plus minus W, the maxima of the function's derivative, and P is the agent's horizontal position. The sensor S transforms the environmental variable E into sensory states. That's the equation again, where D max is the maximum distance between the agent and the shapes. This serves as the input to a neural network composed by two nodes, A and M. Each of the nodes is governed by the following equation. Now, we can skip the greasy details here, but basically I can show you again the picture. Here the two nodes are A, as you see at the center of the big circle, and M. So you see the sensor delta S is bringing information to A, which is then bringing information to M, the two nodes. Here, the equations that describe its behavior. Now, the equations describe the simple model meet the 3M requirements, I think. There are 4 elements, the environment, the sensor, and 2 nodes. The sensor and the nodes perform a computation described by the corresponding equations. And the relations among the equations also seem to correspond to some causal relation between different mechanisms. So we have the sensor S, measures the proximity of the Gaussian shape, include the environment state, E, which is in turn defined by the first equation. So the minimal system described by Burman and collaborators apparently conforms well with the mechanistic framework of explanation. We can easily decompose the system into a number of smaller mechanisms which are then performing computations. Here we have the core elements, here's the sensor, and here are the 2 nodes. Okay, let us now consider back the 2 examples of sensorimotor laws according to Kevin, O'Regan, and Noe in the original paper. First example is the eye rotation. Now, I think this case in particular isn't very difficult to interpret in light of a mechanistic explanation and mechanistic framework. So the eye can easily be seen as a physical mechanism here. It can rotate within that orbit, altering the width and shape of the input projected on the retina. There isn't much to say here regarding to that example, as I think it is a rather obvious example of physical mechanism, basic laws of mechanics in this case. Now, shape perception. Now, featural laws presuppose a form of functional mechanistic composition. I think some features are assigned to specific mechanisms of the brain. Now, in the paper version, for those of you who have read it, I elaborate in more details to these latter aspects. I think there is good evidence that actually Kevin, O'Regan, and Alvin Way assume a kind of featural decomposition of the architecture of the visual system. So basically, they believe that there are specialized, they do not deny that there are specialized areas for doing a particular job in fixing, say, information regarding a particular feature of the visual scene in front of us. In a work done on the differential brain in action, for example, they discuss more detail, for example, how these parts are localized and the problem of neural reuse, in particular when some areas of the brain are damaged and the function is taken over by other brain areas. So the point is, nonetheless, that Noe and Hurley seem to agree on the fact that the featural, different features of our visual perceptual experience are still processed by different areas of the brain, which is perfectly consistent with a mechanistic approach to vision. Okay, now if I'm right, then the examples studied so far are clearly cases of mechanistic explanation. So the sensorimotor theory, in its standard formulation, conforms to a covering law model of explanation. But if we look more closely at the examples we have examined, we can see that the sensorimotor theory is perfectly compatible with a mechanistic approach to explanation. Now we can draw some implications from that. First, now as I said at the beginning, there is a kind of mainstream story about the structure of explanation in dynamic system theory and mechanistic explanation. Now, dynamical models, as Zednik points out, that are amenable to mechanistic analysis resemble computationalist and connectionist cognitive science. And this is precisely the case of Burman minimal cognition model. As we have seen, there are different elements that are performing computations. In that respect, even though we can't study it from a dynamic perspective, it doesn't seem to be a radical alternative to the orthodoxy. This is actually perfectly compatible with what I said at the beginning, drawing a distinction between dynamic system theory on the one hand and the dynamical hypothesis on the other, which is a stronger philosophical interpretation of it. Now, just like computational and connectionist models, such dynamical models presuppose the functional decomposition of a problem, whereby the subcapacities of the explanandum are assigned to specific operating paths of the cognitive system that realize the computations. And that describes pretty well the case of Burman dynamical model and the case of Sensorimotor Laws analyzed by Kevin O'Regan and Alban Lee. But this means that the sensorimotor theory is not in radical opposition with the orthodoxy, so it is rather a complement of it. And in this sense, the sensorimotor theory represents a complementary strategy to the orthodoxy. This actually, I think, is consistent also with all the remarks by Cliff talk about sensorimotor contingencies in computational neuroethology, and as these were meant as a kind of complement to blind connectionism. This reference to older debate, Lakov and Smolensky. Now, this is the price the sensorimotor theory has, in a certain sense, to pay if we want to sidestep the problem of the mere description worry and the problem of determining the role of representations. We can opt for this mechanistic interpretation. But if we opt for the mechanistic interpretation, then the sensorimotor theory becomes a mere enrichment of the orthodoxy it purports to be an alternative of. And now, this is not meant to be a destructive criticism of the sensorimotor theory. Actually, I think it is a welcome claim to accept the sensorimotor theory as part of the broader and enlarged family now of the orthodoxy in cognitive science. So that was my way of saving the sensorimotor theory from the mere description worry. It can, my interpretation, incorporate representations better in the explanatory framework. In the neurosciences, researchers often characterize neural processes as representational, and in that sense, we can easily locate the explanatory role of representations in the sensorimotor theory. And as a final claim, let me point out against one of the defining theses of the sensorimotor theory, that representations do not need to be understood as pictorial or static. So mechanisms are inherently active, as the literature suggests, and talk about representations in neuroscience, at least, is also meant to be something dynamic and active. But we should accept also that it is an open challenge to integrate dynamical and active representations within the orthodoxy. I think this is the good, positive message for future studies. And that was all. Thank you for listening to me. And now I'm curious about your questions.